Swayam Prabha. Digital India. Educated India.
Welcome back to real time digital signal processing lab. So, today we will see that how we are going to find the contour, basically error surface and error contours, and then see that how adaptive filter is going to work. The examples what we have taken is from the book, as you will be seeing that it is from real time digital signal processing, fundamentals, implementation and application. This is the third edition, a book that is from St. Bobley, and then when this thing publisher is John Wiley and Sons. So, here you will be seeing that compute and plot the 3-dimensional error surface for L is equal to 2. So, how it is going to do the thing? You will be seeing that W0 and W1, L is equal to 2 coefficients what it is been chosen, and then you will be considering the mesh grid given by this, define W0 and W1 arrays for 3D plots what you are giving it, and error is given with the equation 0.34 minus 0.6 into W0 minus W1 plus W0 into this thing W0 plus W1 into W1. So, we know that this is the error signal what we wanted to plot, what we have considered in the class also. So, you will be doing that mesh W0 and W1 with error, that is what it says, plot the mesh using where color is proportional to mesh height, add major grid lines what it says. So, you will be adding on the grid, and title is error surface what he has given, and then label x axis is represented with W0 and y label is W1, and then the z label we have is MSE, that is mean square error what it is going to put. So, we will run this code and then see that how it is going to look like. So, okay. You can see that this is x axis is W0, y axis is W1, and then mean square error what you have given it on the z axis. So, you will be seeing that our whatever we saw in the theory. So, you will be seeing the x points y and then z. So, this is the mesh on the grid what you have plotted. So, as we have increased the resolution, so we have to delete from here. Next one is how the contours looks like. Error contours of mean square error, whatever given in the example, we have taken the same example, same from the same book. So, you will be seeing that it is instead of as you have seen the thing here, it is a mesh grid with this, and then this you will be finding out the contour of this error for, that is weights basically W0 and W1 with error, and then we said for the 15 is the iteration what we will be fixing it. So, this also we will run it and then see. So, you will be seeing the you will be seeing 15 what is it, concentric circle. This is how you will be implementing to see that your weight vectors what it is given. If it is more, then you can get your contour and then surface basically using this function. So, now the book we have seen in the last lab that is students how they write their codes and other things. So, we will see that how the book is going to give adaptive filter, because I have this is from the Welch book what I have taken the Think. So, you will be seeing that different books have been referred for different applications or for any of the solutions. You can refer to different books and then you can get the code, and then but you have to understand how they have been implemented and what is the thing happening. So, here you will be seeing that you are taking the order of the filter is 20, that is number of adaptive filter coefficients what you are assuming it, and mu step size is selected as 0.01, that is the convergence factor. So, and then F naught is 1000. Here it is going to generate a chirp start frequency, and F1 is 5000 chirp stop frequency. So, chirp is a basically like you can birds chirp what we call it. So, they will be having different tones what they will be creating it. Same way between 1000 and 5000 hertz you can create in steps of it using this function. And then our step whatever stop is 20, that is time for the chirp to be at F1 what it says. So, that is you will be having steps of 20 with varying thing from 1000 to 5000. So, what you are going to give is your voice with the sampling frequency what you will be taking it from this voice recording dot wave. So, you can record your own voice and then store it as a dot wave and then you can use it. Then we will be using the audio read function in the latest MATLAB versions, and then you will be convert the column to a row vector in this case. The output is going to be in column format. So, you are doing the transpose. So, you will be getting it as in the row format. Then what happens? M is the length of the voice what you are taking it. So, what was the duration of voice? You will take that length, that is number of samples to be simulated, and T is the time which is going to go, that is create a time vector for the chirp command. So, you will be creating 1 to m divided by Fs. So, noise is what you are going to have it as a chirp, which is T F naught T stop comma F1. So, you will have 20 points that is creating a chirp signal here. The function in MATLAB what it is called in as chirp, and then what you will be doing, you are create the noise storage array. X is going from 2 to n, noise of whatever n minus 1 previous one minus 1 you will be downsampling and then 1, this is the step size what you will be taking it. Then initially your weight vector is going to be zeros 1 to n, the length of the filter, that is what it says, initialize the adaptive filter coefficients. Then you will be doing the storage of your voice plus noise, create the signal plus noise in this case, and then you will be what is it, you are going to normalize the storage. How we are going to do it, that is divided by maximum of absolute of D storage what you are taking it. So, that is the positive highest value dividing by that what you are going to do it. Then your Y storage will have 1 to m zeros, that is storage array for filtered noise, and E storage is going to be your errors. You can make, I think you would have got the hint of it. So, which are going to be zeros 1 to m, that is storage array for the cleaned up signal what you are going to have it. So, what is the algorithm for filtering? So, you will be doing J is defined, n to m what you are going to do in this case, that is interrupt service routine simulation starts here, input the 2 channels of data, that is x of L noise j what you are going to have it, interference of noise signal, and D will be the desired signal from D storage of J, that is voice signal plus interference, what you will be taking it as the desired signal. Now, you are going to have adaptively filter the interference signal. So, you will be making it y is equal to 0, the length of the filter what you will go n minus 1, y will be y plus, you can see the weight I plus 1 what we will be considering it, multiplied by x of n minus I. So, then end the thing, and your error function is E is given by d minus y. So, then update the filter coefficients. So, you will be seeing that W of I is updated as W of I instead of calling n I plus 1. So, we can update in the present state itself. So, that our storage is going to be reduced, W of I star 2 into mu star our error x of n minus I plus 1 what we will be taking it. So, this is the loop which will go, and next is prepare the X array for the next input sample. So, you will be taking the next sample from this, and then we will be working on it, and then the interrupt service routine simulation is going to end here, and you will be doing storage after the post simulation. So, you will be putting y storage of j will be y whatever the output after finishing your up to filter length, and E storage of j is going to give you error E. Then you will be listening to the results basically. So, with the original voice what you will see it voice comma fs, signal with interference you will be pausing for 24 seconds, and then D storage which is added with noise you will be seeing with the same sampling frequency. Then you will be hearing the adaptive filters output that is where it has stored E storage will give you the filtered adaptive filter output there. So, these are the plots what you will be seeing it normalized one, okay, how the original voice and then the record voice signal they are overlapped, and then you will be seeing the output. So, we will run the code because we have understood how it is adaptive filter is going to work. So, we will run it.
Testing 1, 2, 3, 4, 5. Why do you need this book? If you want to learn about real-time digital signal processing, DSP, this book can save you many hours of frustration and help you avoid countless dead ends. 1, 2, 3, 4, 5, and stop. Why do you need this book? If you want to learn about real-time digital signal processing, DSP, this book can save you many hours of frustration and help you avoid countless dead ends. 1, 2, 3, 4, 5, and stop. Testing 1, 2, 3, 4, 5. Why do you need this book? If you want to learn about real-time digital signal processing, DSP, this book can save you many hours of frustration and help you avoid countless dead ends. 1, 2, 3, 4, 5, and stop.
So, your word first was the original voice, second one was with added chirp signal. So, you saw that how the chirp signal is generated, it had a varying frequencies, and then later on after adaptive filter you have seen that how the noise is eliminated almost what you can put it, because we will not be able to go up to 0 what we said, the error cannot be completely 0. So, you are seeing this is the audio signal overlapped with chirp signal what you are seeing it. So, if you want to see a portion of it, so I can increase, I think I may have to go back to original resolution, because we try to increase so that you can see the thing. So, the filter thing is plot is going little up. In any case, you can see yourself by that is expanding the thing, how the chirp signal is going to look like. So, now we will see the input and output. So, you will be seeing blue is the input signal and then red is going to be the recovered signal. So, some places you will be seeing that red is little normalized, both of them. So, you will be seeing that it is little low. So, can you guess what will be delay of our output in this case? The order of the filter is 20. Okay. So, there will be 20 samples delay in the case of adaptive filter to start our output. So, you can see initial stages, what delay we are going to get it. So, this, as you can see, it is a marked recovered voice signal from the thing. So, you will be seeing that some of it is whatever you will see the thing, the magnitude is lessened in some places. So, this is the output what you will get it, and then but most of the cases we were able to recover from the noise signal or output. So, in the next class we will be seeing how to implement the same thing in Code Composer Studio, and few more applications what we will be taking up using adaptive filter both in MATLAB and then Code Composer Studio. Thank you.